Hey there YouTube, this is Franco and have a new project. What I have here spread out across the garage are all the pieces to a WorkBee 1000 by 1000 CNC router. Not too long ago I kind of got it in my head that I wanted to do a CNC router, and yeah, you know, it's like all my other hobbies. I don't really need one, but I just thought it would be cool to get into one. You know, the milling machine, the lathe and everything, they're cool and I use them a lot, but I wanted something that I could do bigger pieces on, more of the artistic woodworking type of stuff. And I wanted to, you know, just mess around with, you know, like a double Y-axis gantry style type of machine. So it just seemed like the right time to get into a router. So this is the one I got. What I believe we have here is a Chinese version of the Open Builds WorkBee CNC router. So I guess the WorkBee is kind of like a open source design, like a community forum driven type of thing. And I guess anyone can make the parts and call it a WorkBee. So this is what I got. I jumped on eBay and I found this company. Actually, here's their logo. They are called Bulkman 3D Technology. They actually look like they have a pretty nice website. They sell a lot of different things. But they sell a version of the WorkBee, and on eBay, I was able to buy this for $678. That included shipping. It comes with all the mechanical components and 4 little stepper motors. So these are little tiny NEMA 23 open loop stepper motors that come along with it. So yeah, looks pretty good. I mean, the pieces look good. I hope all the hardware is here that I need. The lead screws look, you know, decent. They're nice and straight. They're not all warped and twisted, so they look pretty good. Hardware doesn't look too bad. Seems to all be of decent quality. It's, you know, fairly well organized and labeled. So everything looks good, except for the fact that it does not come with directions. Found some directions online for a WorkBee CNC router. The pictures sure do look the same. You know, when I look at that picture from here, it looks an awful like the picture on the Bulkman website. So hopefully these directions will be good enough to get me through this. I'll let you know. But yeah, so I'll do some videos while I'm putting this thing together and let you know how this works out. But this is a 1000 by 1000 router, so the working area is actually less than that. I think it's like 800 by 770. Yeah. So the 1000 by 1000 is 800 by 770. So when this is all finished, it should be able to cut a piece like 30 by 31, somewhere in that neighborhood. 30 inches by 31 inches. That's big enough for what I'm doing. All right, well, I'm going to get started and try to get this thing put together. First step in the directions is to build 48 of these V-Wheel Extreme rollers. And you use a V-Wheel Extreme, 2 bearings, and then a shim. So what you do is you push a bearing into one side of the roller. This is what I've been doing. I don't know, this seems to be working for me. I'll just drop it on there. Drop the spacer over the screw, and then put the bearing over that, and then push it together. That way, everything's lined up real nice when you go to assemble it. So I need 48 of those, and it's going to keep me busy here for a little while putting all this together. I'm going to wear my fingers out popping these things in there. Maybe I'll come up with a better way as I'm going, but this is pretty basic stuff. Got to build these rollers. On to step 2.2. So step 2.2, you're going to put some Acme nut blocks onto the left Y-axis, or left Y plate. And what you're going to do, you can see they want you to use these 3mm aluminum spacers to kind of space the Acme block out. You're going to use a few more of those precision shims. So basically, everything was labeled pretty easy, except for the 3mm spacers. I had to get my caliper out and measure those, so those should be, 118 thou, but they're the only thing in there that's even close to 3mm, so they weren't too hard to find. And yeah, so you're going to build this thing up, just like they show you in the directions. And then what you're going to do, well, I'll show you what I did. I used my square, just a carpenter's square, framing square, or speed square, or whatever. Squared up the one block, tightened it down, and then the other block, you're just going to put a little tension on it with your hand while you snug it up, and that's how you get rid of the backlash in the lead screw. So pretty simple. Directions so far have been pretty good. On to the next step. 2.2, things are starting to get really interesting. Now, after you get this far, you have what kind of starts to look like part of a machine, right? We got a piece of C-beam. I can't do this with one hand, but we have a piece of C-beam rolling here, and it's part of the Y-axis. Not sure what to call this yet. I want to say carrier, but I don't know. Anyway, starting to come together. And once again, all of the pieces were labeled except for the 9mm spacers. They were not labeled, so get your caliper out, measure them. They should be 0.354, 354 thou. And these little eccentric spacers were not labeled, but they're pretty obvious what they are. When you look at them, you can see that they're eccentric, and they're labeled 6mm there, some laser marking. So this is pretty cool. All these little, what do we call these things? Solid V-wheel extreme. All these solid V-wheel extreme rollers, they fit down in this extrusion, and they fit pretty good. The idea here is I'm going to drop this, trying to do this with one hand, but do the best I can. So the rollers on the bottom, they get the eccentric spacers put in them. And the laser marking is kind of critical because it helps you get the eccentric spacers oriented correctly. So when you put it together, you want that laser marking pointing straight up, kind of straight up at you like this. That would be maximum clearance. Then after you assemble, you turn those eccentric spacers to tighten up the V-wheel extreme roller. So as you're turning the eccentric spacer, you clamp down more tightly on this extrusion, and that's how you take the slop out of this. And for me, I think I had to rotate all of these just a little bit less than 30 degrees. And that seemed to give me what felt like the right amount of resistance. All right. Got that one built. On to the next step. Step 2.2.3, pretty straightforward. Mounting the stepper motor. All of the hardware was labeled, matching the instructions. The only thing I had to do, the 4 holes and the plate, the M5 tapped holes, I had to run a tap through those. I don't know if the coating that they put on made them tight, or if maybe the tap that they used at the factory or thread mill or however they did this, maybe they didn't have it, wasn't quite right, too small, or wasn't dialed in, whatever, I don't know. The threads were a little tight, so I had to run a tap through them just to clean them out. And after I did that, it was pretty straightforward. 2.4 is pretty simple. You're just going to build the mirror image of the Y-axis. Everything is the same with the exception of the stepper motor. And here we go. There's the left side, there's the right side, and looking pretty good so far. Ready to move on to, I believe, the x-axis. Step 2.3, piece of cake. At this point, I'm getting really familiar with all the hardware and how these rollers work, or should I say the solid V extreme wheel. The only thing that I will mention here, when you look at the plate, one of the countersunk holes is just big enough for the screw. The other countersunk hole is larger, and that's the side that gets the eccentric spacer. They don't tell you that in the instructions, but it's important. You want to make sure you put that eccentric spacer on the side where the countersink is larger. That way, as that screw is moving around there eccentrically, it won't bind up. Where if you try to put it on this side, I'm fairly certain you'd have a problem. As you were adjusting the eccentric, it would bind up. Okay. Next. Step 2.3.2, pretty simple. Mounting the split nut here. And the only thing strange about this, I'm not sure why you do this now. I would have thought you would have done this before the previous step, but whatever. It is complete. On to the next step. 2.3.3 is complete. And once again, at this point, this is all becoming very familiar. You have the double blocks here with the lead screw through it. This plate's pretty simple. It looks like it's the same symmetrical front and back, so I don't think you don't have to worry about countersinks. And at this point, it's actually very satisfying because a lot of the little bags of components are starting to become empty. So that makes me feel like I'm making progress and getting close to the finish line. 3.4 is very similar to all the other steps. But there is one little trick you need to keep in mind, and if you don't do this right, you're going to have to start all over again. When you are finished, this side here, that has to be flush, has to be flat. And the M5 nuts should be back here. If you do it wrong, if you put it together with the M5 nuts on this side, that's not right. You have to start all over again. So just make sure you get the nuts on the right side. And other than that, it's basically the same procedure building these slides. 2.3.5, pretty simple. And only thing I'll say, they have you use 8 different screws or nuts and bolts to hold this thing together, to sandwich these two plates together. That, I guess, is best to overdo it, right? Seems a little extreme to me, but whatever. Yeah, getting closer. 2.3.6, we're building the Z-axis. Directions are really clear. There isn't too much to say about this. The only thing, the directions, they tell you to leave the bottom plate loose. They're kind of clever. The reason for this will become clear later, so we'll just trust them. On to the next step. 2.3.7, pretty simple. Mount the stepper motor. Cable pointing towards the rear. And the only complaint I have so far is all the M5 tapped holes in these black aluminum anodized plates. I've had to retap those. So I would recommend doing that. Just go ahead, before you even assemble this thing, just run a tap. Run a tap through those holes. It'll make your life a lot easier. 2.3.8, we actually have something now that resembles a full working axis. So we have the motor mounted, we have the coupling in there, we have the lead screw in place. So this is where you find out why this lower plate was left loose. Basically what you do is you leave those bottom screws loose, so when you assemble the lead screw, put the collars on and all that stuff, you can draw up this bottom plate and put a little bit of compression on it just to take out any play and the any backlash that might exist here in the bearings on the end. Everything's good. The only thing that I think is weird about this is, remember, I don't even think I can focus on this, but down here, remember this little guy right here? That sort of, that like grub screw that takes the backlash out of that ZAxis nut. You can get to it, but kind of difficult to turn that lock screw down, or lock nut down. So that's the only weird thing that I've run into. But other than that, this has been pretty easy so far. Step 2.4, we're starting to put together the x-axis gantry. This is pretty straightforward, and now it's starting to get big. It's starting to take up some space here, so that's progress. Step 2.42, directions are really good, everything's labeled well, and now it's starting to come together. And this is really the first time I'm getting a good sense of just really how big this thing is. So that's pretty cool. I knew it was going to take up some space, but now I can get a better idea just exactly how much room I'm going to need for this thing. 2.43, directions are pretty clear. Very similar to the other steps that you've gone through for building the assembly. So now the x-axis and z-axis are put together, and we're getting close. I think there is a few more little gussets we got to put in here, and then we're on to building the base. 2.4.4, this is pretty basic, but just installing these little angle blocks to give it a little bit more strength. 2.52, once again, these steps are really similar to previous steps that you followed, just a little bit more challenging right now because you actually have to like physically try to square this thing up just a little bit while you're tightening up these brackets. I don't think I'm going to be able to get this thing permanently, properly squared up and trued up until I have it on a good base, but I'm going to assemble it and get it as close as I can for now. But clearly, now it's looking like a router. 2.53, mounting the Y-axis motors. And once again, starting to become very familiar at this point. Everything's bolted up. The only, like I said, I've had to retap all these 5mm holes in these plates. And the way these bolts fit down through these standoffs, it's kind of snug. So you sort of feel a little resistance while you're tightening them. It kind of binds a little bit, but nothing that prevents you from doing the job. So that's not a complaint, just a comment. Before, we're tensioning up the lead screws, and very similar procedure is done for the other axes. You leave this plate loose by one full turn of the screws, and then you lock up all the collars as snug as possible. And then you draw up these loose screws, and that just kind of compresses and I guess puts any little slack that might exist, it takes it out of it. So I did that to both sides of the y-axis. Looks pretty good. One comment while you're doing that, maybe grab your tape measure and just make sure that your distance here on both sides of the y-axis is the same. You know, you don't want your machine to be cocked or canted or whatever while you're doing this. So just try to get both sides of the y-axis, you know, pretty square as you're tightening this thing up. 2.5.5 is really simple. You're just installing end caps, making it look pretty. It's about as easy as it gets. Okay, so if you recall at the beginning of this, there's two methods for setting up the spoiler board support. Method 1 brings the spoiler board closer to the Z-axis, so it makes the machine a little bit more rigid. If you're only planning on cutting thinner stock, then I guess method 1 is preferred. Method 2 keeps the spoil board further away from the tool. It gives you more clearance for thicker work pieces, but your machine's not quite as rigid. So I'm going with method 1. And a couple of things, you know, here. I'm a little, let's see, I was a little confused here. I had to stare at this for a little bit before I figured out what I was putting together. But basically, what they're having you do is put this piece in. So you need, you know, you're going to put 1, 2, 3, 4 bolts through the front. So you need 4 T-nuts in the front. You're going to put one of those angle blocks here and here, so you need 2 in the top. And then on the inside, you need 6 in the top, 6 in the bottom, because you're going to put three different supports. So you're going to do that for the front one. You're going to do that for the rear one. And what I think I'm going to have to take my end caps off and put 6 more in this in each one of these bottom rows too here. I don't know. I'm going to figure that out when I get that far. So it's maybe possibly something that's a little weird in the directions. And also, what I found was these pieces are exactly the same length. And what I did was I noticed when I put them together, the one in the front was really loose, the one in the back was tight. That told me that my spacing here on my y-axis rails wasn't the same. So I broke everything loose and I adjusted each side so these pieces just fit in, and I do believe the machine is squarer now than it was when I had started this. So there's another benefit of method 1. You get to use these to space out your y-axis rails. 0.62, we're going to put these fasteners in to these pieces we just installed. And when I did this, at first I thought I had forgot something, because I looked here and I'm like, oh man, I don't have any T-nuts in here. How am I going to make this work? But you use these nifty little drop-in T-nuts. These things are pretty cool. So what they do is they fit through the slot and then they rotate to lock into place. And you put them in, you know, just like that. You put them in like that. And then when you tighten up the screw, they turn 90 degrees and they hold everything together. They work really good. And yeah, so they save the day. 6.3 is not difficult, but it is tedious because there's a lot of fasteners. And basically what you're doing is you're putting these brackets here on the end of these supports. And the only trick with this is the one side of the bracket has the holes in the center. The other side of the bracket has the holes closer to the edge. Make sure you get them installed in the correct orientation. 6.4, this is, I think, the very final step. And what it is putting these spoil board supports in. So they give you all these dimensions in millimeters, but what I did was I measured this thing up, and lo and behold, see if I can do this. This is always fun with one hand. It is about 30, pretty close to 36 inches in between these two Y-axis rails. So I just put a mark every 9 inches. So 9, 18, 27. Those were my marks for my supports. And what I did was I kind of, provisionally got everything in place. Then I came back and squared everything up with my little machinist square. And I made sure they're flush that way as well. So that's all sitting on there really nice. The only snag, and I'm pretty sure I followed the directions correctly, but I probably missed something. The directions are probably right, and I probably missed something, but I'm left over with, I have 12 T-nuts left, and I have 12 places where I'm missing a T-nut and a screw. So I guess I need to take the end cap off here and slide those in and finish this up. Hit the last step, 2.8, and this step is complete. So congratulations. Looks good, and these spoiler board supports are in place. I slid those T-nuts in, and I am left only with, all I'm left with are these M5 drop-in T-nuts, some brackets that I assume are for installing this spoil board, and one extra precision shim. That's it. Those are the only spare parts I have left. So they gave me just enough of everything to finish this. But there it is, and I like it. Putting those spoiler board supports in really stiffened this thing up. I gotta tell you, I didn't really think it felt flimsy without them, but now that they're in there, oh boy, what a difference. This thing's really, really pretty, I don't know, sturdy. But, so that's it. So I think I'm gonna let it rest at that for a while. I have some other projects I need to work on, so eventually there'll be a video here of me finishing this thing and making some motors spin. But hopefully, if you're thinking about buying one of these, this was helpful. And if you like this video, please like and subscribe. I always appreciate that. But there it is, the WorkBee 1000 by 1000 CNC router kit. So I'll try to put links to the directions in the description of this video, and any other useful information that I think I can find. And oh look, I think I have a special visitor here in the garage. Winston decided to stop by. Oh, Winston, what's up, buddy? What's going on? You want dinner? All right. So anyway, thanks for watching, and enjoy your projects. And let me know what you think about this router, if you have one, or if you have any tips or useful information. I wouldn't mind hearing about that too. And all right, catch you later.